All right, in this lesson, we are talking about domain and range, which will be a review from Algebra 1. But this time in Algebra 2, we are going to write it in what is called interval notation. So this first page is just to introduce how to use interval notation. And then on the second page, we'll talk about domain and range. Okay, and so for interval notation, we've been working with inequality notation since Algebra 1. And so whenever you have a closed circle, we use the inequality symbols that have a line underneath it because that represents equality. If we have an open circle, we use a strict inequality. So closed, you have the line. Open, you don't have the line. The way I remember that is if you take the time to fill in the circle, take the time to draw the line. If you don't take the time to fill in the circle, don't take the time to draw the line. So in these examples here, we see a closed inequality. And so there is a closed circle at the -3. At 5, we see an open inequality. So at 5, we have an open circle. And because x is between these two inequalities, that means we shade between the two endpoints. And so that would say numbers between 3 and 5, including the 3, but not the 5. We're including the 3 because we have a closed circle. Okay, for this next example, it's saying x is strictly greater than 2. If you need help reading your inequality symbols, the less than sign kind of looks like an L. If it's backwards, that's a backwards L, that's your greater than sign. And so this is a strict inequality, there's no line underneath it, and so numbers strictly greater than 2. And so how that would look on your number line is you would have an open circle at the 2, and you would be shading the numbers greater, that's to the right, 3, 4, 5. Okay, and so for interval notation, it's a little bit easier because you don't have to write the variable each time. You use brackets and parentheses. And so our closed circle is going to correspond to a square bracket. Our open circle is going to correspond to a curved parenthesis. And so make sure your symbols are very distinct so that we can tell, especially if we're trying to grade a test, you can't have some ambiguous symbol for us to try to interpret. Okay, and so for our first example, we had a closed inequality, so that's why there's a bracket. And then at the 5, we had an open circle, that's why there's a parenthesis. For everything strictly greater than 2, because we don't have a right endpoint, it's just going to infinity, our right endpoint will be positive infinity. Negative infinity is to the left. Okay, infinities will never have brackets. And so infinity always has parentheses. And so let's start doing some of these other examples. We're going to write each of these examples in interval notation, words, and we're going to use the graph. And so here we have x is less than or equal to, we have the equality symbol. And so numbers less than makes the L, or equal to 3. And so on the number line, and you don't have to write all the numbers on the number line, you can if you want to. I usually just put the significant value, which is 3 in this case. And then it says, I'm actually going to put it in the middle, less than or equal to. And so that means we're going to have a closed circle for equality, and then less than would be to the left. Those numbers are less than 3. And so in interval notation, it's going to negative infinity for our left endpoint. You always have to go from least to greatest. And then for our right point, we would have 3 with a bracket. Remember, infinity never gets a bracket, always for infinity. Okay, this next example, they're giving us the interval notation from negative infinity to 4 with a parenthesis. So let's go ahead and graph that. I'm just going to put 4 right in the middle. And because we have an open circle or open parenthesis, we're going to have an open circle, and we're shading to negative infinity. That's to the left. And so in words, that's numbers less than, or we can add the word strictly less than. It's understood if you don't write or equal to, but I like writing strictly less than 4. Okay, and so in inequality notation, we would have x less than 4, no line underneath the inequality. Here they've given us the graph. We're between 2 and 6, and we include both the 2 and the 6. We have open circle or closed circles. And so numbers between 2 and 6, including 2 and 6. And so for our interval notation, we would have brackets on both the 2 and the 6. And then in inequality notation, always write least to greatest. And then I always say the alligators eat to the right, because you're writing from least to greatest. And we include a line on both of them. Okay, here it says 5 to infinity. So on my number line, I'm going to put 5 right in the middle. It's a bracket, so I'm doing a closed circle, and it's going to positive infinity, so I'm shading to the right. And so that's numbers greater than or equal to because it's closed, 5. And so here, since it's a one-sided inequality, we still just write x, and then we write the 5, and it's greater than or equal to. Okay, here we have numbers less than or equal to 1. And so in inequality notation, x less than or equal to 1. And then in interval notation, it's going to negative infinity for our left endpoint and stopping at positive 1 for our right endpoint. And we have a bracket because it is a closed inequality or a closed circle. All right, so now we're going to get into some compound inequalities. X is less than 1 or x greater than or equal to 5. So we're going to have 2 intervals to shade on here. So starting with the x less than 1, I'm going to put 1 on my number line, and I'm also going to put 5 on my number line. So at the 1, it's an open circle. There's no line here. And then it says less than, so that's to the left. And then it says x greater than or equal to 5. So we have a closed circle at the 5, and then we shade to the right. Okay, and so this would be numbers less than 1, strictly less than 1. Or numbers, let's just write greater than or equal to, or greater than or equal to 5. Or means you have 2. And then that means we're going to have 2 intervals. So we have the first interval, which is x less than 1, so negative infinity to 1, parenthesis. And then to do the or, you use this U symbol. It means union. Or, and then 5 to infinity. We start at the 5 with the bracket, and then we're going to positive infinity. Over here, we started at negative infinity and stopped at 1 with a parenthesis. Okay, always least to greatest. And so notice, negative infinity to 1, 5 to infinity. It's going from least to greatest. It has to be that way. Okay, here we have what's called a sandwich inequality, not formally, that's just what I call it, a sandwich inequality. We saw one up here for our first example. Those are a little bit easier. And so -5 is our left endpoint with a parenthesis because it's open. And then -1 is our right endpoint, also with a parenthesis because it's open. And then we can put a comma in between. And so for inequality notation, we would have -5, x sandwiched in between, -1. Alligators always eat to the right. And then we are not going to put any lines underneath these because these are parentheses and these are open circles. And so these are numbers strictly between -5 and -1. Okay, now this next example, we're gonna look at a lot. It's all real numbers. And so if you were to shade that on the number line, you're just shading the whole number line from negative infinity to positive infinity. And so interval notation is negative infinity to positive infinity. And then in inequality notation, we don't really write infinities with inequality notation. That's not proper form. And so usually we're just going to use the all real number symbol, which is 2 R's, kind of like, or 2 lines like an 11, and then connect your R to the back line. That symbol means all real numbers. Okay, next we have another compound inequality with 2. And so we have, for our first interval, our left endpoint is negative infinity, and then our right endpoint is -1, and this one gets a bracket because it's a closed circle. We'll have a union symbol in between. We pick back up at 2 with a parenthesis because it's open circle, and then it's going on to positive infinity, which always has a parenthesis. So negative infinity to -1 bracket union, and you have to write these all on one line. That's the proper form. And then 2 to infinity. Okay, so in inequality notation, our first interval says numbers less than or equal to -1. And then our second interval says numbers strictly greater than 2. And so we can't write this as a sandwich because there's 2 different inequalities. It's not sandwiched between them, it's the outside. And so that's how you know you need the word or. Okay, and so here's our interval notation, or our inequality notation. We just need to write the word or in between them. Okay, here we have 1 to 4 with parentheses. So 1 to 4, that means it's a sandwich inequality with x in the middle. And no line underneath these because we have parentheses. And so on a number line, that would be the numbers between 1 and 4. Both with open circles. Here we have x is strictly greater than 7. So we have our 7 with an open circle, shading to positive infinity. So 7 to infinity. Here we have another sandwich inequality between -2 and 2. Both have closed circles because I see 2 brackets, 1 on each. And so sandwich inequality, x is in the middle. Alligators eat to the right. Both get a line. All right, this last one's pretty important. It's how you exclude a value. So this symbol means does not equal. Makes sense. It's an equal sign with a slash through it. And so on a number line, you would have an open circle at that 4. you would have everything shaded to the right and you would have everything shaded to the left. So that includes everything from negative infinity up to 4. And then it also includes everything greater than 4, but we have to just skip over the 4. And so how we would write that in interval notation is negative infinity to 4, parenthesis, union 4 to infinity. It's important that you don't stop at 3 and 5, because some people think if you're excluding 4, you need to stop at 3 and 5, but you can still have the fractions in between 3 and 4 and the fractions in between 4 and 5. And so that's why the parenthesis is telling us don't include the 4, but include everything on each side of the 4. All right, so now we are going to talk about domain and range. And so for domain, we're talking about all the x values. And then for the range, we're talking about all the y values of a function. Okay, and so the way I remember that is it's alphabetical order. D comes before R, X comes before Y. And so when you're focusing on domain and range of a graph, I like to imagine putting the function in a box. And so when you're packing this function into a box, you want to touch the function on all sides. You don't want any room for it to move around. And so here's the box around my graph. And so for domain, I'm looking for the x-axis. So that's x, this is the x-axis. And so I'm looking for where the sides of my box go. And so one side would start at -5, the other side would be at 5. And so if we're using interval notation, we would have -5 to +5. And because these are closed circles, we are going to have a bracket on each one. In inequality notation, we're going to have -5 to 5, and then our inequalities are going to have lines underneath. It's a sandwich inequality. And then for our range, we're scanning from bottom to top along the y-axis. And so you're looking for where the top of your box is and where the bottom of your box is. Okay, and so the bottom of my box would show up at 0. And then the top of my box would be at +5. The 5 gets a bracket, and then so does the 0. As long as there's not an open circle, it's automatically closed. So anytime there's an open circle or something like an asymptote, we'll look at those later in the year, those are situations you would use parentheses. But if there's not a open circle or asymptote, you use brackets. Okay, and so for inequality notation, you need to use a y when you're talking about range. But other than that, it's the exact same thing we were just doing. Okay, when you're talking about max and min, that refers to outputs of a function. And so in this case, it's your y's. And so you can really just look at the endpoints of your range. And so the max is at 5, because that's the highest endpoint, and then the minimum is at 0. Okay, for this next example, I'm going to go ahead and draw the box around the function. And so the left side of my box would be here at -2. The bottom of my box would be here at -4. The right side of my box would be here at 6. And then the top of my box would be +2. So for domain, we're scanning from left to right. And so -2 to +6. -2 has an open circle, so we're going to use a parenthesis. 6 has a closed circle, so we're going to use a bracket. And so in inequality notation, we're going from -2 to 6, and we need a line under the 6. For the range, we're scanning from bottom to top, so -4 all the way to 2. least to greatest, always least to greatest. And then at -4, there's a closed circle, so bracket. And then at 2, we have an open circle, so parenthesis. Okay, and so our minimum here is -4. And then here we would want to say the maximum is 2, but because that point is not actually there, the open circle means it's excluded. And so we get infinitely close to the 2, but we don't actually equal it. And so in this case, there is no maximum. You can say D&E if you want to be fancy, stands for does not exist, or you can just say none, because we get infinitely close to 2. So 1.9, 1.99, 1.9999. You can always get closer. And so because that point doesn't exist, we do not have a maximum for this function. Okay, number 3, I'm going to go ahead and draw the box. And so for domain, scanning from left to right, the side of my box is at -3, and the other side is at +3. So -3 to +3. And then we need an open circle, so a parenthesis. And we have another open circle, so another parenthesis. So no lines on our inequality. Forgot to do the range over here. So -4, y, 2, alligators eat to the right, and we only need a line under the -4. Okay, for range, we're scanning from bottom to top. So -5 to 4. Now this is where it gets confusing. There's not an open circle here, so it's automatically closed. You can draw a closed circle anywhere there's not an open. And so we do need a bracket at -5, but at 4 there's an open circle, and so we're going to use the parenthesis. So -5, y, 4, and then we need a line under the -5 and no line under the 4. The maximum, just like the last example, doesn't exist because we would want to say 4, but there's a parenthesis. That means we get infinitely close. And then our minimum is at -5. We do equal that minimum point. Okay, and so here we have a circle. Technically, this is not a function. This comes up on your homework. Anything that fails a vertical line test. So if you draw a vertical line down a function or down a graph, if you hit that function more than once, here and here, for example, this is not a function. Some of you may remember that from Algebra 1. Not a function, fails the vertical line test. So on the homework, you're just looking to see if they fail the vertical line test, to see if it's a function or not. But you can still talk about the domain and range. And so just like the last examples, you can draw the box. And so the left side of my box would be at -7. The top of my box would be at +7. Right side of my box would be at 7. And then bottom of the box would be -7. Okay, and so my domain is going from -7 to +7. Brackets, because we don't have open circles. And then same thing for the range, -7 to +7. And we need brackets. Okay, and so use your Y for range, use your X for domain. And then we have both our minimum and our maximum. Our maximum, is kind of in the wrong order, is 7. Our minimum is -7. Okay, on number 5, this is the first time we're seeing an unbounded function. So if I were to try to draw a box around this, I could draw the bottom of the box here at y equals 0. But if I try to draw the right side of the box, it's going to bust right through the box. Same with the left side of the box. It's just going to bust right through the box. And then same with the top. And so we can't put sides to our box or a top to the box. And so when we're trying to identify domain, remember we're looking for the sides of the box. And so because I can't put a left side, that means it's going to negative infinity to the left, and then it's going to positive infinity to the right. And so if you want to extend this to positive infinity, think of your x-axis, just like the number line. It goes from negative infinity to positive infinity. And so our domain is going from negative infinity to positive infinity. We could also use the all real number symbol, because that means all real numbers. And then for our range, we do have the bottom of the box at 0, but we don't have the top of the box. That means it's going to positive infinity, and negative infinity would be down here if you want to extend your y-axis. And so this one stops at 0. We have a closed circle, so a bracket, but we don't have an upper endpoint because it just, as it's going to the right, it's going up as well. Same with the left, it's going up. And so 0 to infinity with the parenthesis. And so this would be y is strictly or is greater than or equal to 0, because we have that bracket, we have that point. And so because our maximum is infinity, this is another case where we'd say there is no maximum, but we do have a minimum at this 0. Okay. Number 6 is the exact same thing we just did, only instead of a V shape, it's a U shape, but all the same answers. Okay. The last example I want to do, and the rest you can check with the key, is this example here. This is what we call discrete data. Discrete means disconnected. And so notice these are just isolated points. We don't have lines connecting them. It's kind of like a scatter plot. You don't want to connect them because they would have connected them if they wanted them connected. Over here, we had what's called continuous graph. And so when you think of the word continuous, don't think unbounded. Continuous doesn't mean it goes on forever, which can be confusing. Continuous in math means it's connected, meaning you can draw it without picking up your pencil. And so every single example we've done so far is continuous. They're all connected. When you're dealing with a disconnected graph, you cannot use interval notation. You have to use set notation. Okay, and so in set notation, you're using squiggly brackets, and you just list the values from left to right or bottom to top, least to greatest. And so for my domain, sometimes I like to go ahead and label all the points. So this is -1, -2, -3, -4, -5, -6, -7, -8. And so this point is -8, 0. This is -4, +3. This is +2, -3. This is 3, 4, 5, 6, 7, 8. This is 8, -2. This is 2, 5. And this is 0, 2. And so domain is all our x's. And so go from left to right, -8, -4, 0, 2's, we see it twice, but we're not going to list it twice, and then 8. So -8, -4, 0, 2, don't double list, and then 8. Kind of like my class roster. If I see you twice, I don't list you twice, because then it looks like I have extra students. So that same principle applies for domain and range. And then for our range, scan from bottom to top, -3, -2, 0, 2, 3, 5. So -3, -2, 0, 2, 3, 5. Okay, and so our maximum is the 5. We do have that point there. And then our minimum is -3. And the other thing I want to mention about this is it actually fails the vertical line test. So if we didn't have these 2 points on this vertical line, it would still be a function. It would be a discrete function, but it can still be a function if it's just isolated points. Here, it's not a function because it fails the vertical line test. That's something that comes up on the homework, so I just want to make sure I reviewed that for you.